It's not easy being a teenager. There's the angst, the emotions, the raging hormones. And although hormones do play a big role in puberty, the brain is going through a lot of changes too. Neuroscientists are learning that some of the most puzzling teenage behavior may actually have some real benefits. Legally, you're considered an adult when you turn 18. But from the neuroscience perspective, your brain is really still developing.
And the current literature suggests that it's about around age 25 or so is when the brain finishes the period of adolescence.
This is Dr. Adriana Galvin, and she runs the Developmental Neuroscience Lab at UCLA. The brain develops from the back to the front, so the prefrontal cortex is the last region to fully develop.
The prefrontal cortex is the part of the brain you need to make good decisions, to think about the future, think about consequences.
You can kind of think of it like the Spock of the brain, logical, calm, and collected. And then deeper in the brain, there are these emotional systems like the limbic system that are more interested in immediate gratification. They're sort of like Captain Kirk, a risk taker and a bit emotional. During the teenage years, the limbic system develops really quickly, and the prefrontal cortex is trying to catch up. Eventually, as individuals become adults, the prefrontal cortex will increasingly have more influence over behavior than the impulsive part of the brain. So, without a fully developed prefrontal cortex, you can kind of see why teens might be more impulsive or just worry less about future consequences. Another brain region that's really active during adolescence is this thing called the striatum, and it's a key part of the brain's reward system. Let's say you find 20 bucks on the street, or someone gives you a cookie. The striatum goes off, and it releases dopamine into the brain. Adriana's lab discovered that the teenage brain is super sensitive to different rewards like sugar and money. Way more than in the brains of adults and children. And all this activity in the brain's reward center, it may actually serve a purpose.
We asked teenagers to come to the lab and we scanned their brains while they performed a learning task. They were shown a picture of a butterfly and 2 flowers, and they were asked to guess which flower the butterfly would land on.
After each guess, they were given feedback. When the teens got it right, their striatum would get really active.
They would learn over time that the butterfly preferred one flower over the other. And everybody learned this task. But what we found is that the adolescents learned it more quickly than adults and with greater accuracy.
So having this reward center that's hyper-responsive to feedback actually helps teenagers learn from their environment. But this same region of the brain is also connected to risk-taking. Data from Adriana's lab suggests that teens with a more reactive striatum are more likely to engage in risky behavior and to enjoy it.
Rather than ask how you keep your teenager from taking risks, because we know the brain is really oriented towards risk during this time, it's better to ask, how do I provide opportunities for healthy risks?
Like trying out for the school play, even if you've never acted before, or asking someone out on a date. Those are real risks to a teenager, but they're not the kind of risks that parents typically worry about.
It makes sense from an evolutionary perspective that there's a time in life when teenagers want to become more independent, seek out new opportunities. In the animal world, this would translate into looking for new food resources or foraging behavior. And in teenagers, it often manifests as risk-taking behavior and simply moving away from the family unit.
Teenagers are going to make mistakes, but they've got this brain that's encouraging them to learn and explore and push boundaries.
So adolescence is a really special time, and I think we don't appreciate enough their energy and their ability to lead and to motivate, and how excitable they find life in a way that we maybe we don't later in life.
Our brains keep changing throughout our lives, and researchers at UC Berkeley are learning that if you give people a little bit of power, it can have a big effect on the brain. Learn more by watching our video here, and be sure to subscribe for more Figure 1.